You know the basics of Terraform. You have run plan, you have run apply. But when an interviewer asks you, how do you handle state log that's stuck? Or how do you manage multi-environment refactoring? Do you have the answers? Today, we are debugging your interview preparation. I have compiled 8 Terraform questions ranging from entry level to lead architect. If you can answer all 8, you are ready for a DevOps role. Let's see how many points you can score. Alright, level 1, the foundation. What is the difference between Terraform plan and Terraform apply? Now, don't just say one shows changes and one makes them. To impress an interviewer, you need to explain the state refresh. When you run Terraform plan, Terraform does 3 things. First, it reads your code. Second, it refreshes the state by checking your actual cloud provider to see what's actually there. Third, it creates an execution plan. It's a preview that tells you exactly what will be created, updated, or destroyed. Terraform apply, on the other hand, is the go button. It takes that execution plan and makes the API call to build your infrastructure. Pro tip, in real production environment, we almost always run Terraform plan -output equals to TF plan first, and then apply that specific file. This ensures that the exact changes you reviewed are the ones that get deployed. No surprises. Level 2. This is the plumbing of Terraform. What is a provider and where does it actually come from? Think of Terraform as a universal translator. It does not actually know how to build an AWS EC2 instance or an Azure SQL database on its own. It needs a provider to do that. Provider is a plugin that contains the code necessary to communicate with a specific API, whether it's AWS, Google Cloud, Kubernetes, or even GitHub. But where do they come from? They are pulled from the Terraform registry. When you run Terraform init, Terraform looks at your code, sees which provider you have declared, and download the necessary binaries into a hidden folder called .terraform. A pro tip, interviewers love it when you mention that providers are versioned. You should always lock your provider versions in a required provider block. Why? Because if a provider update changes the way a resource is built, your code might break during the next deployment. Lock the version, save your weekend. We are through the basics. Now we are moving into the real world territory. Why should you never commit your state file to a Git repository? There are 2 massive reasons for this. First, security. The state file is a plain text map of your entire infrastructure. But more importantly, it often contains sensitive data in a clear text. If you create a database or a virtual machine with a password, that password is sitting right there in the state file. If you push that to GitHub, you have just leaked your credentials to anyone with the access to the repo. Second, state locking. Git is meant for code collaboration, not for source of truth database files. If 2 engineers run Terraform apply at the same time and push to Git, you will get a merge conflict in your infrastructure state. That is a nightmare to fix. Solution? Tell the interviewer you use remote backend like AWS S3 with DynamoDB for locking or Terraform Cloud. This keeps the state of your machine, encrypts it at rest, and ensures only one person can change the infrastructure at a time. Great job making it this far. Now let's talk about code organization. These questions separate the people who hacked it together from the people who follow clean code principles. What is the difference between a variable and a local? And when should you use one over the other? Think of variables as your inputs. They are the parameters of your infrastructure. You use variable when you want to allow a user or a CI/CD pipeline to pass in a value, like a region, an instance size, or an environment name. They are meant to be changed from the outside. Locals, however, are internal to your code. Think of them like temporary variables in a standard programming language. You use local to reduce repetition or to perform logic. Here's how to explain to an interviewer. Use variables for things that change between environments. Use local to keep your code dry. Don't repeat yourself. For example, if you need to construct a complex naming convention like project env service region, don't type that everywhere. Define it as a local and reference it. It makes your code cleaner and much easier to debug. Welcome to level 5. We are officially entering senior territory. At this stage, the interviewer is not just asking if you can write code. They want to know if you can build a system that a whole team can use. The next question is, what is Terraform module and what is the standard module structure you should follow? Module is essentially a container for multiple resources that are used together. Think of it like a Lego block. Instead of writing the code for a virtual network, a load balancer, and an auto scaling group every single time, you wrap them in a module so you can call them in one block of code. But the key here is the structure. An interviewer wants to hear that you follow the standard module structure. That means every module should have at least 3 files. First, main.tf for the actual resources. Second, variable.tf for the inputs the user provides. Third, output.tf to pass data back to the parent module. One tip, if you really want to stand out, mention versioning. Just like providers, you should source your modules from a private registry or a specific Git tag. This prevents a change in the module from accidentally breaking 50 different projects that are calling it. You build once and you reuse everywhere. Now we are talking about the messy reality of DevOps. Not everything goes according to plan. Sometimes the infrastructure is already there or a specific resource is behaving badly. So the next question is, if a resource was created manually in the Cloud Console, how do you bring it under Terraform management? And second part, what do you do if a single resource is corrupted and needs to be recreated? For the first part, the answer is Terraform import. You have to tell Terraform, hey, this ID in AWS or Azure belongs to this block in my code. But here is the trick most people miss. Import only pulls the state. It does not write the code for you. You still have to write the HCL to match what's in the cloud. For the second part, if a resource is glitched but Terraform thinks it's fine, you use the replace flag during your apply or taint in older versions. Tell them that Terraform taint is technically deprecated in favor of the -replace flag by running Terraform apply hyphen replace equals to resource name, you are forcing Terraform to destroy and create that specific resource without touching anything else. It's a precision tool for fixing ghost bugs in your infrastructure. Welcome to the high stakes round, level 7. At this level, the interviewer is looking at your architectural judgment. They want to know if you can design a system that scales for a whole company. Someone says use workspaces, but a lead architect might say use directories. How do you decide between using Terraform workspaces versus separate file structure to manage your dev, staging, and prod environments? This is a classic debate. Workspaces are built in and allow you to use the exact same code with different state files. They are great for managing different instances of the same thing, like testing a feature branch. However, for production environments, most lead engineers prefer a separate directory structure, using something like TerraGrunt or just plain folders. Why a separate directory structure is recommended in production environments? Because of blast radius. In a workspace, if you make a mistake in your code, it's shared across all environments. If you have a separate directories, you can have different versions of your modules for dev and prod. You can also have a stricter permissions on the production folder. In a workspace, if you have access to the state, you usually have access to all environments. In a professional, high security setup, isolation is usually better than convenience. This is it, level 8, the boss fight. This question does not test your knowledge of success. It tests your knowledge of disaster recovery. Most people hope they never have to do this, but a lead engineer knows exactly how. The question: your Terraform apply crashed midway due to a network timeout. Now your state is locked. Or worse, it thinks a resource exists that actually failed to create. How do you manually manipulate the Terraform state to fix a corrupted environment? This is where we put down the hammer and pick up the scalpel. You have to use Terraform state command suite. If the state is logged, you first try Terraform force -unlock with the lock ID. But if data itself is wrong, for example, if Terraform thinks a load balancer exists but it's actually gone, you use Terraform state rm. This removes the resource from the state file without trying to destroy it in the cloud. The most dangerous but powerful tool here is Terraform state pull and push. If the state is truly corrupted, you pull the JSON file, manually fix the broken metadata in a text editor, increment the serial number, and push it back. Warning: tell the interviewer you always take a backup before doing this. Showing that you prioritize safety even in a disaster is what makes you a lead engineer. How many points did you score? Don't worry if you missed a few. Terraform is a journey, and every red screen is just a bug waiting to be debugged. Comment below if you want more such videos and let me know which question was the hardest for you. If this helped you feel ready for your next interview, hit that subscribe button and join us. Thanks for watching, keep building, and I will see you in the next one. Bye for now.